Hi guys, can you hear me? All right, okay. I don't know what went wrong. Okay, guys, something went wrong with the restream, but can you hear me still? Can you hear me still? Am I still online? Yes, all right, okay, we can hear you. But then somehow something happened that it's not responding. I don't know why. All right. If I end it, then it will be I won't get back to it. All right. So we just continue until it's I don't know why it's not responding because I wanted to share the screen. It says that it is not responding. Right. Yeah. uh, Kejap eh. Right, okay, so I don't know what happened. It's not responding. Okay, never mind. uh I don't know, you keep on pushing and so on. Right. But you can hear me. Okay, you can hear me. That's good. But how, I don't know why I cannot share the screen. Yeah, I cannot share the screen. Okay, so in that case, never mind. We will just use the textbook, right? So the reference is going to be your textbook. We will wait until it responds because I don't want to end it. Okay, I don't want to end it. Even the attendance also I couldn't give. It all just went gray. All right. I don't know what's wrong with this thing. Even though we pay money, also still got issues. All right. Okay. So we are going to go into 3.3. Hmm? All right. Okay. Movement of substance across the plasma membrane in living organism. All right. Active and passive transport in a living organism. All right. Okay. So before this, we saw that what is the difference between passive transport and active transport. All right. So we saw the differences. So passive transport, remember the dance, right? Ah, right. So it is without using energy, no energy. All right. It is from higher concentration to lower concentration until they reach equilibrium and there'll be no energy involved. All right. So that is the idea lah. All right. Okay. Gases exchange between an alveolus and a blood capillary through simple diffusion. So now we are going to see what are the processes, live processes. It is still not responding, but then you still can see me. Yeah, that is good. All right. I cannot share anything. I cannot share anything. But now, man, let it go. Let it go. But you have your textbook with you, right? So refer to the textbook. All right. Okay. So here, what we are going to do is we are going to see what are the common in the question. common things in the question, that is seeing that is using the passive transport and active transport. All right, so that is, but then you don't have to worry much. Okay, you don't have to worry much. All right, you don't have to worry much. Why? Is because we will be seeing all this later on in respiration, in kidney, everything we will see. But only now you feel like, oh my God, there are so many things. What are all these? But you don't worry. We will be seeing this again and again as we go along. Okay, so as we go along, we will see this again and again. Okay, so that is how it is. All right, so you don't worry about it. But then for now, you still need to know lah. Okay, so passive transport ini is gases exchange between the alveolus and the blood capillary is through your simple diffusion. Even just now in Form 3 also I was teaching that. Okay, the alveolus itu, the gases are going, they are diffusing from the alveolus to the blood capillary according to concentration gradient. Okay, next we have the reabsorption of water occurs by osmosis. Okay, it occurs by osmosis through the renal tubule. So that means when we want to filter the blood, okay, when we need to filter the blood, what will happen is the reabsorption, okay, of reabsorption ini will be reabsorption will be done by osmosis. You know, the reabsorption means you have absorbed it during your food intake and all that. Okay, you have already diffused into the blood. Now what you're doing is you are second time you are absorbing it back into your blood. So that is why they use the word reabsorb. And we cannot use the word absorb because ada budak yang tanya, ada budak pula, sorry lah ada pelajar yang tanya, teacher, why not absorption of water? When they use the word absorb tu saya bagi salah. When I give them a wrong, they ask, teacher, why is it wrong? Okay, why is it wrong and so on. So the thing is very simple. Why is because it is reabsorption of water through osmosis. Why is because first time you have absorbed it into your blood in osmosis, using osmosis. All right. Okay, now the blood is second time. Second time they're absorbing it back into the blood. So that is why they use it as reabsorption. All right. Okay. So absorption of water by plant root hair cells by osmosis. This is satu lagi lah. Okay, absorption of water by plant root hair cells by osmosis. So how the water comes into the plant is also osmosis. Okay. Fructose in the villus. In the villus, once we have digested all your food, we have fructose. Right? So that fructose is one of the monomer. Nanti later in the chapter 4, you will learn what is monomer. Alright? We have carbohydrate. We have three types of monomers. Fructose, galactose, and lactose. So these three are monomers which will be absorbed into the blood when the diffusion is over. So fructose is absorbed by facilitators. So all these are passive transport. So remember, passive transport means from high concentration to low concentration until they reach equilibrium and no energy is needed. Alright, so those are the examples of everyday life stuffs that we use. Okay, so every time, everything. Okay, so the next one, guys, you all still can hear me? Am I still online? Just because it's still gray. It's not moving anywhere. I think if I press the X, that's it, it will end. Just give me some validation, please. Like Hantu, every time they have the ghost thingy, they say, okay, please validate that we have someone here. Please validate if you have someone here. Adi macam itu. Dia stop responding. I don't know what to press. If I press, the only thing which is red is the red color, is the X. So if it's, yeah. Alright, okay. So yeah, so that is the idea lah. Okay, so you validated. Okay, so that means I can continue. Nanti or not, I'll be talking alone, like shot sendiri je. Right? Okay. Active transport. Active transport also another very, very important process. Why is because you need to accumulate. Either you need to accumulate or you need to get rid of it. Okay. So either you need to accumulate or you need to get rid of it. Okay. So that is the idea. All right. Okay. So the active transport in organism occurs during absorption of glucose and amino acid in the villus. All right. Absorption of glucose and amino acids in the villus. Okay. That is one. Right. So the second thing, it is the reabsorption of glucose through the renal tubule in the kidney. So in the kidney, what will happen is they will be taking in by active transport. Because glucose is a very, very important substance. You cannot just absorb until they reach equilibrium. Cannot. You have to keep on, keep on, keep on, keep on, keep on, keep on. Aku ni suka menari lah pula So keep on, keep on, keep on. Why? Is because you need to accumulate the glucose. Right. So active transport also occurs in some toxic substance. Tapi you don't have to worry lah, because in the for your level too, these are the things that they have spoken about. So you stick to it. Don't complicate life. All right. Okay. So glucose through the renal tubule reabsorption. That means once they want to filter the blood, the glucose is reabsorbed using reabsorption. Okay. So the transport of sucrose from phloem to tissue. Okay. Later on in Form 5, you will learn about vascular tissues. All right. Phloem tissue and all that. Okay. So in the phloem tissue, what will happen is they have they use active transport to transport all this. All right. Okay. Absorption of mineral ions by plant root hair cells, also by active transport. Because there is some case that they need to increase the concentration in the root hair cells. So what they do is they have to increase the mineral ions, so they will pump in. You see, when you're dealing with active transport in it, you can feel free to use the word pump. Right. Of course, you can use the word absorption and so on. Like they say, pumped in actively is also can be accepted. Because the word pump means it is against the concentration gradient, against the one force. Okay, that is the general meaning of it. All right. Okay, so far so good, boys. Any questions? Oh my God, it's still gray and it's still pusinging. Still pusinging. Ayo. How to take attendance? There are 12 ekor here watching. I will still give the attendance, but the attendance to Tabule. Can you all, those who are here, can you please say yes, 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 so that I can go back to YouTube and find the attendance when I record the recording too? Say hi, 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 according to your name too. Round and round. Yeah, it is great. It's going round and round and round. The wheels on the bus go round and round. I think Kala saya punya murku pun. What is this nonsense? Guys, hi guys. Alright. Ridiculous lah. When you want, in hurry, I just finished my Form 3 class, Then come here pula, ini macam punya masalah. Ya. Kan? Say hello, hello, hello. Ini jam keberapa ni? Boy. Anything, as long as your name is there. Right? Okay. So, yeah, reabsorption of mineral ions by plant root hair cells. Alright? So, that is the idea. Okay. So, the air movement. Okay. Air movement. This is in the alveolus. Okay, guys. At your level, you must be able to draw the alveolus and the blood capillary. You must be able to draw. Because this thing, even in Form 3, they already introduced to you. Okay. So, and you know that our new format, there are a lot of drawings included. Because we have already taught you the lateral, the dorsal, the ventral, and all that. So you must be able to draw. Okay. So remember, when you're dealing with the alveolus, you must draw them one cell thick. You cannot draw just 2 layers. It is one cell thick. Yeah. So that is the idea. Okay, and remember, guys, another very, very common problem with the students is they always think when we inhale oxygen, and when we exhale carbon dioxide. No such thing. Okay, no such thing. We inhale air with a different composition, and we exhale air also, but in a different composition. Okay, so that is the idea. Right? Okay. So mineral ions absorbed in the root hair cells through active transport. And so it is root hair cells itu by active transport. This is one of the active transport thingy. All right. So that the water can go. This is root hair cells. And the one that is like that. Is your root hair cells. All right. But when we draw, we don't draw it like that. La. We draw just one like that. La. And ridiculous la. But then in the book, they draw like that. Something is definitely wrong with me today. No, I'm still frustrated. I'm still pushing. Pushing. And look at my English. We have an English, such a Manglish, pushing. I hope nobody else watches. Ridiculous. Okay. Now I'm going to introduce to you the concept of isotonic, hypotonic, and hypertonic solution. All right. So this is a very, very important concept. All right. So this is a very, very important concept where the concept of the isotonic, hypertonic, and isotonic will determine the direction of the movement of water molecules. All right. So actually it refers to solution. This is one thing that you all have to remember. Okay, we are at what page? Hey, your textbook, open your textbook since I can't share screen. 58. Open page 58. I tak boleh type pun. Okay, page 58. So there are three types of solutions. All right. So this actually the word hypo, iso, and hyper, it refers to solution. Okay, so solution. So isotonic, hypotonic, and hypertonic, these are referring to solution. So a lot of students have the habit of referring to the cell. All right. So which is actually, in my point of view, it's actually wrong. Right? It is actually wrong. Yeah. All right. Okay. All right. Okay. So yeah. This one actually we usually apply the concept of osmosis. All right. By osmosis, where it goes from high water potential. High water potential means it has a lot of water, to low water potential, which is low water. Right? So that is what. Okay, the concept of isotonic. Guys, you have to remember when you are dealing with this hypo, iso, and hyper, you must have a system. You must have a system where you have A and B, and you have a selectively semi-permeable membrane separating these two environments. All right, so you have two environment. You have something in between called a semi-permeable or selectively permeable membrane, and you have it's a system. It's a system. All right. So okay, when we use the concept of isotonic, that means these A and B, these two environments, are actually have equal concentrations, equal amount of water. Okay, they both have equal amount of water. That means A and B, if you refer to your textbook page 58, okay, let me see whether dia sudah stop pusing or not. Oh, belum stop pusing lagi. I think dia takkan stop pusing untuk the whole day. Alright, so it is isotonic to each other. Okay, so it is isotonic to each other. Okay, so there is no net movement of water. Okay, there is no net movement of water. Okay, what do you mean by no net movement? Ada pelajar yang kata, oh teacher, osmosis does not happen. Alright, because you have to remember, water will go from high concentration of water to low concentration of water. But here now, both of them are equal. If both of them are equal, do you think the water stays here? No, they still go move like that. This is exactly a dance. They still move like that. But then they come back. But then you don't have to worry because it goes to the left, it comes back to the right. It goes to the left, it comes back to the right. Hilarious, right? Hey. Left and right, left and right. Imagine I'm doing this in the class. Hey, I do this, I do this, in the class. I dance. Tapi of course lah, that time all not as good as this lah. Kan no sari, no necklace, kan normal teacher, right? Dancing like that, right? So now you see, I have gelang, I have a necklace, so it makes it more interesting. Isotonic is like that. So the water will go here, come there, go here, come there, but it is zero. Two molecules move there, another two will come here, another two goes there, another two will come here. So they will balance it because they are equilibrium. Nanti exam nanti you pergi menari-nari like that. Hilarious, lah. I need my coffee, lah. Something wrong with me. My second cup of coffee of the day since 4 a.m. in the morning. Okay. So yeah. So the solution is isotonic to each other and there is no net movement of water. Don't think there's no osmosis. Osmosis occur, but they occur in a two goes there, two comes here, three goes there, three comes here, four goes there, four comes here. So they are balanced. All right. Okay. So far, guys, any questions or not? You can start dancing. Your mom will think, what is this student was dancing in a ini pa kelas PJK ka kelas tarian India ka? Apa ni mereka semua menari-nari ni? Tak apalah nari lah. What is in life lah? Right? Kejap saja. Life so short, so sweet. Nari lah. So what? What's your age? I don't care. I never bothered about my age. Any questions so far about isotonic? Anything that you want to ask? No? You all okay? All right. Okay. I understand. Yay! Amir Hakim understands. Good. All right. Remember, isotonic is when they already reach equilibrium. So they are like going there, coming there, going there, coming there. That's how it is. All right. Okay. So let's move on to your hypotonic. So hypotonic refers to a place, refers to an environment which has high water potential. That means it has a lot of water, less solute compared to the other part. Like I said, this is a system where you must have two environments and they are properly separated by a selectively permeable membrane. All right. So now in this case, hypertonic and hypotonic actually they come hand in hand. You cannot separate them. If one environment is hypotonic, other environment has to be hypertonic. Right. If one has a lot of water compared to the other one must have less water compared to the so that is this both ini you jangan belajar separately, no. If A is hypotonic to B, then B must be hypertonic to A. That is the meaning. All right. When A is hypotonic to B, then B is hypertonic to A. That is the meaning. Okay. And the water molecules will diffuse by osmosis. So from high water potential to low water potential. So water molecules will always diffuse from hypotonic to hypertonic. Right? So always will diffuse from hypotonic to hypertonic. Alright? And when you are hypertonic, that means you have a lot of solute but less water molecules. That means you have low water potential. That is the meaning. Alright? Okay, so far so good. Please read it and tell me, boys, if you have any still pusing. All okay? So far so good. Are you still in line, and or am I still in line? Okay, teacher. Hypertonic, hypotonic. Remember, it is comparison. All right, you have to compare with someone. Yeah, so that is the idea. All right, okay. Okay, next we have, what are the effects when you place different cells? Okay, you namely animal cells and plant cells in different concentration, hypertonic and hypotonic. All right, okay. So let's read this. The cell cytoplasm contains solutes such as glucose and mineral salts. Actually, you may ask, teacher, that's all. No, actually they have more. But usually the cytoplasm, their concentration is increased by not everything there. All right, only certain things like glucose, mineral salts, some of them, they have the ability to increase their concentration. All right, so this is what we call as intracellular fluid. So whatever that is the inside the cytoplasm, we call it as intracellular fluid. All right, okay, each cell is surrounded by extracellular fluid. That means if I am the cell, I have intracellular fluid. So around me, I have extracellular fluid. That means whatever that is surrounding me is what we call as extracellular fluid. Okay, so that is the idea. All right, and water will always diffuse according to the concentration gradient. Wherever the water potential is higher, that means it's hypotonic to other, the water will always diffuse from hypo to hyper, or from high water potential to low water potential. That is the law. Right? Okay. So now, all right. Okay. So the effects. So usually what we do is we will place a red blood cell. Okay. Teacher, why not other cells? You can do that too, but you cannot see any difference. Everything is clear. But if you put red blood cells, since they have color, so it's very obvious. Okay, so that is why we like red blood cell. Plus, this is one of the most important thing that actually goes on all this. Alright, okay. So when the red blood cells are placed in a hypotonic solution compared to them, that means the red blood cell is hypertonic. The intracellular fluid in the red blood cell is hypertonic, but the solution outside is hypotonic compared to it. So what will happen is, remember, water will always will move from hypo to hyper. So the water will diffuse from the cells, into the cells by osmosis. So when the water start coming in and coming in and coming in, remember, we don't have plasma membrane to hold it. So finally it will burst. All right. So this is what we call as hemolysis. Okay, this is what we call as hemolysis. Right? Okay, what is the effect of hypertonic pula? Alright, what is the effect of your hypertonic pula? Okay, the hypertonic itu, when they place in a hypertonic solution, the water will move out of the cell by osmosis. Alright, so the red blood cells are placed in the hypertonic solution. The water will move out of the cells by osmosis. Now, the cell is hypotonic. The intercellular cells, fluid inside the cell is hypertonic compared to the solution outside. So, outside has a low water potential. Inside the red blood cell has a high water potential. So, the water from the red blood cell will go out, diffuse out. They will cause them to shrink and they look like a durian practically. I miss durian. I name is durian. Okay. So yeah, that is crenation. Alright. So these are the terms that you need to know. Right. So when they shrink, they look like a durian. So they call it as crenation. Right. Effect. Okay. What will happen when you place the red blood cell in an isotonic solution? Remember, if it's isotonic solution, the concentration is the same. So it goes right, left, come, go out, come out, come in, go out, come in. It will be equal. It will be same. It will be normal. No changes. Right. So the water comes in, the water goes out. Same. Yeah. So that is the idea. Okay. Next. What is the effect of when you place a plant cell? When you place a plant cell, same thing. The cell you have to compare. Now the solution is hypertonic to the cell or it is hypotonic to the cell. When you place it in a hypotonic solution, the water there outside there has a higher water potential. Water will diffuse in by osmosis. But do they burst? Hey guys, you all are there or not? Validate. Validate. Do they burst? Still pushing in, no? Still pushing in. Do they burst? Does when water diffuses into the plant cell by osmosis, do they burst? No, darling, they don't. Amar Daniel, no, they won't burst. Why? Kau mesti tak ada buku ni. Tengok ni. Because they have cell wall. The plant cells do not burst because they have cell wall, which is rigid and strong. Now we are at page 59, I guess, 60. Open your textbook to page 60. Yeah? So it will be rigid and strong. So the turgor pressure is important. So why is because when the vacuoles has a lot of water, they push the cytoplasm. So they give like a turgidity to it. Right? So causes the guard cells to swell to allow the stomata to remain open for photosynthesis. So water potential difference in it has a lot of impact on the plant. Right? Unlike us, they need to regulate a lot of water content in their cells in order to perform some activity. You will see all this later. All right? But remember, same thing. If you put them into a hypotonic solution, the water will start coming in by osmosis and the thing will be turgid, but it won't burst. It will be like, but it won't burst. Yeah? All right. Okay, what will happen if you put them into a hypertonic solution? Aduh, kesian dia. So if outside is hypertonic, that means inside the cell must be hypotonic. Okay, so the water, instead of coming inside, which is the ideal situation, the water starts going out. I'm losing. So what will happen is slowly the cytoplasms will lose the water, the cell, the vacuoles will lose the water, the cytoplasm will lose the water, and the cytoplasm will be pulled away from the cell wall. It will be pulled away from the cell wall because they are losing water. Remember, your cytoplasm is also water. Right. So they will be pulled away. So yeah, that's what happens. Right. Okay. So this is what we call as plasmolysis. Yeah. It causes the leaves and the stems to bend downwards and wilt. So they'll be like. Right. Okay. So we call this plasmolysis. But can they regain their original nature? Okay. Can they regain their original nature? Can they come back to normal or not? What do you think? No, they won't. can they come back once they plasmolyze ready? Can they come back to original nature or not? What do you think? Ah, yes, they can. They can undergo deplasmolysis. They can undergo deplasmolysis. All right. But you cannot simply call a cell deplasmolized before they undergo plasmolysis, you know. They only can undergo deplasmolysis after they have undergone plasmolysis. Itu penting. All right. So that one you have to remember. Okay. So the effect of isotonic solution. This one is again like this lah. Water go in, come out, water go in, come out, go in, come out until same. All right. So the cells in this condition we call them as flaccid. Okay. So flaccid ini means it is either they are normal or they have lost their water. Itu ialah the term that we use for flaccid. Okay. So either they are normal, that means normal, nothing is happening to them, or when they lost water also we can call them as flaccid. Yeah. All right. Okay. So far so good, guys. Any questions? I'm planning to finish this chapter today. But unfortunately can't share screen. All you can see is only my face. And I didn't even put enough powder today because I thought I'm going to be so small at the side. So I didn't even bother. I didn't even touch up after the phone 3 glass. But who cares? Do you care? You don't care, right? Okay. Never mind. All right. You all okay? Validate. You're still here. Validate. I need validation all the time. Hi, guys. Okay, understand, teacher. Okay, validation came through. All right. Okay. So next are the experiments lah. When you come back, I tell you there are so much of experiments, but I just hope that we have time to do. All right. We have time to do. But then, yeah, lah, we have to formulate some way to do it, to get that done. All right. Okay. So I'm going to skip all this part because this is all experiment. I'm planning to finish the syllabus today. I mean, the chapter today. Yeah, okay. So across the plasma membrane and its application in everyday life. Yeah. So osmosis has a lot of application in our daily life. All right. So how you are regain once like, okay, when you're in the dapur, when you're in the kitchen, you saw your mom's kangkong, it's like slowly wilting. So you can suggest to her, Mom, why don't you put them into the water? Quick, put them into the water so that they can regain their freshness. Right. So you maybe you've accompanied your mom to go to sayur pasar, beli sayur di pasar, can. So you take a kangkong, it looks super fresh. Then after that, by the time you come back home, the kangkong is like, So what do you need to do? Shower them with water. So that's why maybe you have realized in Giant, if you go to bigger supermarkets and so on, or in a wet market and so on, what they do, they always will spray water. Right? So they will always spray water. Why? Is because when they spray water, it will look fresh. So if we also don't look fresh, we have to spray water. For me, very simple. If you want me to look fresh, means you just give me 1 barrel of coffee. I'll be fresh. All right, so that is the idea. All right, okay. Then we have across the plasma membrane has many application in our daily lives. For example, rehydration salt. This one when you are going again, you're having diarrhea and you're having like excessive vomiting due to food poisoning and so on. The first thing the doctor will give is like, no medicine. Go drink this. Right. Why? Because it replenishes the water and also the electrolyte. Okay, so the solution itu, you cannot simply dilute, you know. They will tell you, okay, this one packet is like 250 ml of water. So you dilute it inside and slowly you drink it a little bit by little bit. All right. So what will happen is the electrolytes itu will replenish the minerals inside, the lost minerals by and okay. So they will replenish. So you don't need to worry. Alright. Or some if like very very terrible, memang dia langsung tak boleh. You have had diarrhea for nearly 6 times or more. That is severe diarrhea. So you have to give intravenous. Okay, intravenous. Okay, so apabila kita bagi intravenous itu, what will happen is they will give you saline solution, which is isotonic to your normal blood. Right, so that is the idea. Okay, so isotonic drinks, athletes, they drink isotonic drinks. Why? Because they want to replenish not only their water, but also minerals which are lost by perspiration. Okay, liposomes. Ini apa ni? Vesicles that contain aqueous solution. Alright, so they protect drugs. Because you want the drugs to go to certain place only then disembers. Okay, you don't want them once you put in the already they become na makan pun susah and the effect also less. So what they do is they make these liposomes and so on, which is an aqueous layer that slowly when they go to certain places, all right, only then when they reach the targeted cells, only then they will start pecah. Okay, so that is ideal. The reverse osmosis very common. Kowe, Amway, Kowe, Kuku. Right. So what they do is they force the water particles, okay, to move out through a selectively permeable membrane. Right. So what will happen is all the solute will be staying there. Only the water will be fresh water only will be coming out. Right, and they will apply pressure to it. Right, to fasten the process lah. So that is the idea. Right. So yeah, we have successfully finished this chapter. So maybe the next class itu we will do some revision lah. Okay, we will do some revision, and when the school opens, we will be going into chapter 4. All right. Okay, guys. It's still pusinging. Okay, still pusinging. Pusing-pusing pun kita dah habis satu kelas. Alright. Okay, guys. Any questions? Before we call it a day, I have another class at 11:30. I don't think so, teacher. Okay, guys. There are 14 of you, so I'm expecting the 14 of you to attendance. All right. So I will send it into our group, our Telegram group. All right. Later, not now. Okay, but also I will still validate through this one. I don't know whether this one will be saved in my recording or not. I don't know. I have to double check and see. All right, so far so good. Okay, so don't worry. Next week, what I'm going to do is we're going to recap the whole thing and we will go through everything again. All right, okay, dears. Bye. See you. So sorry, something is just off today. All right, kejap. I ambil gambar. I want to put into our Telegram group ini. Kejap. How it is berpusinging. Okay, kejap. Aduh, macam ni lah dia pusing. This is how it's still pusinging. Okay, bye dears. I'm going to press the X button. Okay, bye-bye. Ay, X pun tak boleh ya? Boleh dah.